Hello everyone, in this video we will be going to discuss the problem segregate zeros and ones in an array. So the problem description is that we are given an array of zeros and ones in random order. So we have segregate zeros on the left side and ones on the right side of the array. Basically we have to sort the array. So the input format is first argument is array of integers consisting of zeros and ones only. So like this input is for example a 0 1 0 and second input is 1 1 0. So we will output the array like 0 0 1 and 0 1 1, that is zeros on the left side and ones on the right side. So let's see another input. So for example the input is 1 0 1 0 0 1 0. So we should output the array 0 0 0 0 1 1 1. So as there are four zeros and three ones, so we have to add four zeros in the starting of the array and three ones in the end of this array. So as mentioned in the problem, the first approach which came in mind is sorting the array. So if we sort the array, we will get zeros in the front and one in the back. So but the sorting algorithm will take a big of n log n. We should try to reduce the time complexity as much as we can. So what we can do is we can simply create two variables that are count 0 and count 1, and we will count the occurrences of these numbers. So if a is equal to 0, if the element is 0, we will increment our 0 counter, and if it is 1, so we'll encounter our 1 counter. So after that we will for if count 0 is greater than 0, that means we have enough zeros to place in the in the left or in the starting of the list. So we will set at the front of the list the value 0, and after that if the count of 0 reduced to 0 or less than 0, so we will set 1 as 1 will be the remaining then. So but in the question we have been given that we have to traverse the array only once, as the time complexity will not vary because it is also a big of an approach. But we should try to think like, can we do in a one single loop only? So yes, we can do in a single loop by using two pointer approach. Like we will initialize our j as 0 and we will traverse in the list, and if we get a 0, we will replace with the index j, and in the increment j, increment the j counter. So we can see the dry run, then our understanding will be better. So this is the dry run. We will initialize our I and j at the first 0 index first. Then after, if encounter 1, we will have to do nothing, we will increment the ri index. But if we encounter a 0 like this, in this case we encounter a 0, so what we'll do is we will swap with the index j. This is the j, so we'll swap with 1 and 0. So we'll get 0 in the front and 1 at the ith index. Then we'll increment I again. Again we encounter here 1, so we will have to do nothing. We will increase the counter I. So again we get a 0. So if we get a 0, we have to swap with j and increment the j. So we have swapped and we get 0 0 1 1 0. After that, at the last I is at the last, so it encounters 0 again. So if it is a 0, we have to swap. So we get 0 0 0 1 1 like this. So if we see, we can find out that this is the desired answer. So we will return, as time complexity is big of n in this case also, and in the previous case it is also like big of n and big of n big of 2n, that is also big of n. But we did in this case, we are only using a single loop. So this is much better. So this was the solution for the problem.